Okay, so we are going to discuss about acceleration due to gravity in this video. So we have got Earth here and a point P above the Earth. So it's marked where is the center of the Earth. O is the center of the Earth. P is a point above the surface of the Earth. Now OP is equal to R, and we have got the radius of the Earth labeled as RE and the height of point P above the surface of the Earth as H. So again, we want to know what is acceleration due to gravity for the Earth. So acceleration on the surface of the Earth is given by this formula. G is equal to capital G ME over RE square. Capital G is the universal gravitational constant. Its value is given as 6.67 into 10 to the power negative 11. ME is the mass of the Earth. RE is the radius of the Earth. Now, if we want to find the acceleration at an altitude at h, so before what we saw was acceleration at the surface of the Earth. Now we want to find the acceleration at an altitude h. Altitude means the height from the surface of the Earth. So here point P, as we can see in the picture, it is at a height h from the surface of the Earth. So in this case, the acceleration is given by this formula. A is equal to G RE over R whole square. Or we can also write it as RE over RE plus H. What's that? What is that what we have written here? So this R which we see here, it can also be written as RE plus H. You can check in the diagram that R is equal to RE plus H. Okay, let me just remove these marks from here. Okay. Now R is the distance of the point from the center of the Earth. So here point P is at a distance R from the center of the Earth. And we are trying to find out what's the acceleration due to gravity at this point P. Okay. H is the height or the altitude from the surface of the Earth, which we can see is labeled on the diagram again as H. That's the height of P from the surface of the Earth. Now let's just quickly analyze a few things about this formula. If R is equal to RE, that means we are on the surface of the Earth, and that means A will be equal to G, which we can put in the formula also. We can check. If I put R as RE and RE will get cancelled out and we will get it as 1. So let me just show you that here. G multiply RE over RE, because R is equal to RE whole square. So these two can get cancelled out and I will get A is equal to G. Now, so at the surface of the Earth, we have got acceleration as G, which is 9.8 meter per second square. If R is greater than RE, that means we are above the surface of the Earth. In this case, acceleration due to gravity is going to decrease by inverse square relation. What's the meaning of inverse square relation? Now for that, I have to first rub a few things from here. Let me just rub this out here. Okay. So acceleration due to gravity is going to decrease by the inverse square relation, which we can see from the formula. If you just open up the formula, A is equal to G RE square over R square. So we see that A, which is acceleration due to gravity, it's going to be inversely proportional to the square of the distance. Okay, so that's A, inversely proportional to the square of the distance. Now there's quite interesting fact here that even though the acceleration due to gravity decreases as the distance increases, but it will never reach 0. Okay, it will keep on decreasing. It might become very, very small, but it will not become equal to 0. Let me end this video with the Earth's gravitational field. If you want to show it on a diagram, how we will show it? We will show it with some arrows, which are actually the vectors which point towards the center of the Earth, and that's how we will show the gravitational field of Earth.